All right, so today's lesson's on 4.4, factoring quadratics. We'll do a couple little review problems here before we get into factoring, just to kind of help us out. So let's recall, we have been doing this a little bit, but we are going to distribute the following binomials. So binomials would mean that there are two terms. All right, so we've been working on things like x plus 2 times x plus 3. We've done a little bit of distributing with that already. So maybe you were taught FOIL, that first, outer, inner, last. That's fine. But I'm taking x times x to get x squared, taking x times 3 to get 3x, 2 times x to get 2x, and then 2 times 3 to get 6. We do want to know how to distribute those things well, because that will help us check our answers when we go to factoring. It'll help us also see that there's some common patterns that happen, like we have some combinations of our like terms. So I've got x squared plus 5x plus 6 for my final answer. All right, so what we're going to do when we factor is we're going to be given that, and we need to put it in this form. All right, that's considered factoring. All right, so it's kind of, some of my students have called it undistributing, which I don't think is a real word, but in a sense, that's what we're doing. We're trying to put it into that multiplied form. All right, so we need to see these different patterns that are happening. I need to notice that while I'm taking the x and the x, I'm always getting that x squared. All right, so if I start with an x squared, I know to put an x and an x in each set of parentheses. All right, something else we'll notice, I got this 6 here. That 6 comes from multiplying the 3 and the 2. So those last two numbers are always going to multiply to this last term. All right, and then these end up getting combined to get that 5x. We want to look at those patterns and see those to help us factor more efficiently. All right, so we'll keep that in mind. And we are going to, what you'll see often is the term factor completely. All right. So our first example, I've got 9n squared minus 24n. This one's going to be a little bit different than what I just distributed above. All right, but something with factoring completely, make sure that you are always looking to factor out the greatest common factor first. All right, always look for that. All right, so if I look at number 1, there is a number that divides both 9 and 24, which would be 3. And they also have a common variable that they share. They each have at least one n. So 3n is considered that greatest common factor, so I'm going to pull that out in front. And then I put what's remaining inside of my parentheses. All right, so when I factor that out, it's kind of like division. I'm not truly dividing by 3n because I'm not getting rid of the 3n. So sometimes I think of it as more of a multiplication. 3n times what would have given me 9n squared? Well, 3n times 3n is 9n squared. All right, then 3n times what would give me my negative 24n? Well, that would be negative 8. Okay, and that's all we're doing. So check for that greatest common factor. Sometimes there's going to be more steps after this. In this case, there is not, and I'll talk about when we'll see more steps beyond that. But you'll have problems where this will just be your answer. All right, in Math Excel, when you start to put those parentheses, it'll have a red parenthesis until you close the other parenthesis, and then it won't be red anymore. I always have some students question and kind of panic about what that's about, but maybe you've already noticed that when you type in points. Okay, so we'll look at another one similar to that. All right, so I've got 7x squared plus 49. So we're first looking for a greatest common factor, so as a number and or a variable. So if I look at 7 and 49, I want that number the largest number that divides into both. So that would be 7. The first problem I had, I put the n out in front. Will I be able to put x with that 7? I will not, because this 49 does not also have an x. They need to share that in common. So there will be no x there. So then I'm left with x squared plus 7 times 7 would give me 49. All right, you can always double check. If I distribute this back through, I should get what I started. So factoring is just putting it in another form. It's not changing the value of anything that we had before. Okay? All right. I want to talk about one more kind of like that. So if I use 4y squared minus 16. Oh, do I want to use that? Scratch that. I'm making this one up on the fly right now. This is why I don't do this. I don't want to do that because it's going to create something harder. So I'm going to go with 24y. All right. Okay. The reason why I'm bringing this one up is I might have some students that would say 2y is what I pull out in front. And 2, yes, does go into 4 and 24. Y is in both, but is 2 the greatest common factor? No, 4 is the greatest common factor. And so I will have students that get frustrated because, I mean, if they continued with this, they'll get an answer, right? And they'll have 2y minus 12. All right, they'll get an answer. If they distribute it, they get what they started with. So they get upset when I would mark something like that wrong, or when Math Excel will say that that is wrong. You must use the greatest common factor. It will be important later on next quarter. You'll have to trust me on that. But if you're not using the greatest common factor, you're not going to be able to simplify certain things correctly later on. So we need to make sure we're practicing it correctly now. All right, so I'll quick change this. So that would be a 4y, and then I would have y minus 6. So always double check, even within your parentheses here, were there any other greatest common factors? Before I had 2y minus 12, and so 2 would have went into both of those. So that was a clue that I did not have something done correctly. Okay? All right, let's take a look at something a little bit different. So if I gave you x squared plus 6x plus 8. All right, first we look for a greatest common factor. Is there a number that would divide into all 3, or a variable that I could pull out of all 3? There is not. All right, so from here, I'm going to do a different strategy. It's going to go more like what the very first review problem was like. All right, I'm trying to write this in a multiplied form, so I'm going to set up those 2 binomials to multiply into my x squared plus 6x plus 8. So it's going to look like this. All right, if I'm given an x squared, that means I need an x times an x to get that x squared. All right. From here, if I was to distribute what I have out, remember to get that 8, these last two numbers need to be multiplied together to get that 8. So I need to think of some things that multiply to 8, like 8 and 1, 2 and 4. Those are my only options. But only one of those would make sense, because also when I multiply this out, so I'll use everything as plus since everything is positive above, we must combine those two numbers to get 6x. So that would mean they need to be a 2 and a 4. It would not matter where I put the 2 and where I put the 4 in this case, because they both have a plus in front of them. It wouldn't make a difference. If you're not sure quite how I came up with that, you can go ahead and distribute it. X times x gives me my x squared, takes care of that part. X times 4 would give me my 4x, then my 2x. Those together combine to get that 6x. That's why they must add together. And then the 2 and the 4 would multiply to 8. Okay, so when you're coming up and you're setting up the two binomials, like I did above, you're looking at it must multiply to your last number and add to the one in between. Okay, so this is what you'd be typing in Math Excel. I'd multiply it out to double check that my answer is correct. All right, that's not something that I would have to include. Okay, let's try another one. So if I gave you 3x squared plus 30x plus 75. So first thing, I look for a greatest common factor. Is there a number or variable that I could divide out of each term? 3. So I will do that first. Just like we did in the very first problems, divide everything by 3, so then I'll have x squared plus 10x and plus 25. Okay, if I distribute the 3 back through, I get what I started with, but I still have this x squared remaining, so whenever there's an x squared, you need to always continue to try to take it to this next step, because we could possibly break it into an x times an x and keep going. Once again, everything is positive. So now here's my last number. That means it will need to multiply to 25, but add to 10. So there's not many things that multiply to 25, so my options are 5 and 5 and 25 and 1, and 5 and 5 will add to the 10. When you go back and double check if this is correct, distribute your x plus 5 times your x plus 5, and then multiply the 3 through, just like in the order that we went in when we factored it. All right, make sure you're including this 3 into your final answer as well. Otherwise, it will mark it wrong in Math Excel. And we will go ahead and head to lunch. All right, and we are back. So you may have done some diamond problems with other teachers with factoring, where you put these and you put the 25 on top and the 10, and then you put your 5 and 5. Go for it. You can continue to use that. I do not use that just because I look at the numbers right here and then put them below. So for me, it's an extra step that I don't find necessary, but if that's something that you really like and you have used, you can continue to use that. That's fine. So up to you. All right, we're gonna try a few more examples here. All right, so I've got x squared minus 29x plus 100. So as always, look for our greatest common factor first. There would not be any, since I have a 1 in front of my x squared, and there's not an x throughout the whole problem. So I'll go ahead and go to this next step. So x times x will give me my x squared. Remember, we need to multiply to 100, and now we are adding to a negative 29. So sometimes I'll put my signs in there first because I'm thinking about if I'm multiplying to a positive number but adding to a negative number, the only way that can happen is if both of those are negative, right? Two negatives will make a positive, but if they're both negative, it's still going to combine to a negative number. All right, so sometimes I like to throw my signs in there first. And then from here, I got to think about some things that multiply to 100. So like 10 and 10, 2 and 50, 4 and 25. And those two numbers would have to combine to 29. So my option would be 4 or a negative 4 and a negative 25 to make that work. Okay. Let's look at one where I have a negative in front of my x squared. Now, technically, there are no greatest common factors that we would have to pull out, but I always pull out if there's a negative in front of my x squared, I would always factor that out in front. It's going to be easier for you to factor the next step if you divide everything by a negative 1, so I'll change all of my signs. Otherwise, I would have had to set up in my parentheses a negative x and a positive x, and then I have to do a lot more guessing and checking to put the correct numbers in place. So my suggestion is to always pull that negative 1 out. It will help you with other problems we do later this quarter as well. So then I have x times x. This time I'll be multiplying to a negative 24, but adding to a positive 2. So if I'm multiplying to a negative number, that means one of my numbers need to be positive and one of my numbers would need to be negative. All right, so things that multiply to 24, 2 and 12, 3 and 8, 6 and 4, 1 and 24. But I need to combine them to be a 2. I'll need one of them to be negative. So 6 and 4 are 2 apart. So I'll need a negative 4 and a positive 6 so that that would combine to positive 2x. Okay. All right, we're going to look at some special forms for factoring. So factoring the difference of perfect squares. So some examples of this would be x squared minus 4. All right, x squared is considered a perfect square because x times x gives you x squared. 4 is a perfect square because 2 times 2 gives you 4, or there's something to the second power that you could get those numbers or that variable with. And you're always going to be missing that middle term, and it's always subtracting because that's your difference. All right, so there's a nice little pattern that happens each time with these problems. But if you want to rewrite it as x squared plus 0x minus 4, you can do that as well. What's going to happen is I'll have my x and my x. To get my x squared, I'm multiplying to a negative 4 but combining to 0. So that means when I add these two numbers, they are going to cancel out. So I need the same exact number, but with opposite signs. Okay, so this will be the setup for all of your difference of perfect squares problems. They'll always look identical with a sign switch in the middle because they're always going to be missing that middle term. So when they combine, you would get 0. So if we look at another option, like this, if I give you 4x squared minus 1, this would be one where that 4 cannot come out in front because 4 does not divide 1, so it's not a greatest common factor. But 4 is a perfect square, so is x squared, and so is 1. So when I set this up, I'll have one positive in the middle and the other will have a negative because they must cancel each other out because it's missing that middle term. All right, the only thing that multiplies to 1 is 1 and 1. But now I'm multiplying to 4x squared, so I'm not going to use just x and x. I need 2x and 2x to get to 4x squared. If you don't quite believe me that that would work, we can distribute this. That would give me 4x squared. There's that first term. Then I've got a negative 2x. Then I'm going to add 2x. Those cancel out. That's where I'm missing that term. And then my negative 1 at the end. So if you recognize this pattern, it should be pretty quick for you to factor. This pattern comes up a lot. So your general form for your difference of perfect squares is a squared minus b squared. And that factors into a plus b times a minus b. So if it was a plus in between the a squared and the b squared, we could not factor it. If one of those is not a perfect square, we could not factor it. So it must be a difference of 2 perfect squares. All right, so watch for that pattern. All right, we have one more type of factoring problem that we'll take a look at today. There's times, kind of like the one that we just did, right up here, where we have a number or an a value. When I'm talking about a, I'm talking about ax squared plus bx plus c, right? We're still talking about quadratics here. When that a value in front of x squared is not 1, and it's not a greatest common factor, that does make the problem a slightly more difficult. All right. So we're going to look at a couple examples where we are going to factor when that a value is not equal to 1 or a greatest common factor and what that looks like. All right, so our first example like this is 2x squared plus x minus 3. All right, so I have a 2 in front of the x squared. That's my a value. It is not 1, and 2 does not divide the other numbers that I have, so I do not pull out the 2. These first two terms still have to multiply to 2x squared. So now I'd have a 2x in one and an x in the other. That would still multiply to 2x squared, so that's fine. All right, but from here, it's going to be a lot more picky about where my numbers go. All right, when it was just written as x and x, I'm multiplying those outer and inner terms by 1 every single time. This time, whatever number I put right here will have to be multiplied by 2 before I combine it to get the next number. All right, so think about this. For example, I have a 3 here. The only thing that multiplies to 3 is 3 and 1. Would 3 and 1 combine to 1? No, it doesn't. But the number I put in this spot multiplied by 2 and then combined with the number in this spot would. Okay, kind of a lot to think about. The good news is 3 and 1 are our only options. All right, so what I usually tell students when they're first trying this, some of you can think ahead and you already know where it goes, great. Just plop it in there. Plop in 3 and 1 and use a pencil when you're working through these. all right? And then check your answer, all right? It needs to be negative, so one of them has to be positive, one of them has to be negative. I've purposely set this up wrong because I want you to see what happens when you do this wrong, and then you just try it again, okay? So I know I got my 2x squared, right? Here's the part that's tricky. This is going to give me a negative 6x plus x. That does not combine to 1x. So I know I have these in the wrong spot. All right, so I'm going to fix that. I'm going to put 1 there instead and 3 here. What will that give me? Well, now I have negative 2x plus 3x. That will give me 1. I guessed where my signs went. So if I would have got a negative 1, then I would just have to flip my signs around. All right, and now I've got the answer. So there's a little bit more guessing and checking, I guess you could say. I know some teachers have taught kind of like a window, and they've taught me, and I never remember how to do the window, so I just gave up on it. And I just tried this problem twice, and I usually can do it faster than someone doing a window. Okay? If you've been taught something with that, you absolutely can use it, but I'm not going to use that strategy because I don't remember how to do it, to be honest. So let's try another one. So if I gave you 3x squared minus 5x minus 2. So my a is 3. That's larger. It's not just 1. And I can't divide that 3 out. So we'll do a similar thing as what we did last time. This time I'll put a 3x and an x. That multiplies to 3x squared. I know that for sure. It still has to multiply to 2. Yes, we are combining to negative 5, but the numbers that are multiplying to 2 are not combining to negative 5 because I'll have to multiply one of them by 3 first. Okay, because of this 3 here. And it's not a 1x, it's a 3x. Okay, so we got to figure out where do I put the 2 and where do I put the 1 so that it would combine to a negative 5 if I multiply one of those by 3. Maybe you can see it right now. Maybe you can't. You can plop them in there again. So 2 and 1. One of them has to be positive, one of them has to be negative. Double check your work. I know I've got a 3x squared. Here would give me a negative 6x plus 1x. That would give me negative 5 and negative 2. This is correct. Okay. We'll do one more problem for our notes today. So if I gave you 6x squared plus x minus 2. My a is 6. I cannot factor 6 out. 2 goes into 6 and 2 goes into 2, but that's a 1, so I can't pull up 2 either. Still make sure you're checking for those greatest common factors because it's going to make it easier to factor if you have one. This one's harder than the last 2 we've done because there's actually 2 possibilities. I could have 6x and x or 2x and 3x. So if there's a number here and it's not prime and you've got more possible factors, that will make it slightly more difficult because I might not know offhand which one that is. Okay, it couldn't be either. There's only one that's going to work. All right, so you kind of just have to go with maybe your gut instinct. Typically, I don't do this one first. For one thing, it's combining to a small number, and I already have a 6 out here. So it seems unlikely to me that that would be the one that I would try first. All right, so I'm going to go with this side first, and if I didn't get anything to work, then I'd resort back to the 6x and x. Once again, we have to multiply the 2, so we got 2 and 1. So if I go over here in this side, if you remember back to what I told you about greatest common factors, I would never put a 2 here because they share a common factor. So that should have been pulled out already. And I was not able to pull out that factor. So that would be an incorrect place to put it. So my only option would be for a 2 here and a 1 here. If that makes sense to you, you will be much faster at getting to these problems. If it doesn't, you might just take an extra try or two if you don't realize that's a possibility. All right, and then I need one of them positive, one of them negative. I'm going to double check that my signs are correct because they're not. So I've got 6x squared here. I've got negative 2 times 2x would be negative 4x plus 3x, then minus 2. So I got a negative 1x instead of positive 1x. So that means I have my signs flipped the wrong way. So I'll quick change those. So we will need I forgot what I had. This would be a negative and that would be a positive. So then I get plus 4 and minus 3. And then I've got it. So it might take a couple of tries, but hopefully not too many if you're kind of thinking ahead a little bit. All right, that's our lesson on factoring. Your homework assignment is long. There are a lot of problems, but there is no new homework assignment tomorrow. So finish what you can today, and you'll have some time to work on it tomorrow as well.